Now let's see about thread synchronization in Java. First, let's see what is the need of thread synchronization. So that means what are the problems which encounters if there is no synchronization, and then an example program which demonstrate without synchronization, and then we will see what is thread synchronization, and we can implement thread synchronization with the help of synchronized method as well as synchronized block. So we'll see those two. First, let's see what is the advantage of what is the need of thread synchronization. Let us assume that there are two threads. The first thread is producer thread, whereas the second thread is consumer thread. So let me have a shared buffer. So this is nothing but a buffer, shared buffer. Here in shared buffer we are using a variable called count. Here count denotes the number of items which are in the buffer. Suppose if count value is 5, then it specifies that there are 5 items in the buffer. Suppose if count value is 2, then it specifies that there are 2 items in the buffer. Here producer thread produces an item and then places the corresponding item in the buffer. Once it places an item in the buffer, it increments the corresponding count value by 1. Let us assume that producer thread is producing an item called 10. So it places the corresponding item in the buffer, and after that it increments count by 1. Initial value of count is 0. Now count value will become 1. Then assumes that producer thread produces one more item. Let us assume that item is 20. So 20 will be placed in the buffer, and then it increments count by 1. So now count value will become 2. So likewise producer thread will perform the operations. Now let's see what consumer thread will do. Consumer thread consumes an item from the buffer and then it decrements count value by 1. Let us assume that consumer thread consumes first 10 from the buffer and then it decrements count value by 1. So it indicates that the buffer contains only one item. So likewise producer thread and consumer thread will perform the operations. Let us assume that here the value of the count is 7. Let us assume that here we have 7 as count value. So it specifies that there are totally 7 items which are present in the buffer. Okay. Let us write the logic for producer thread here. So what the producer thread will do? Producer thread produces an item and then places the corresponding item in the buffer and it increments count value by 1. Generally, any thread performs operations internally in the form of registers. So the first step here is the corresponding count value will be stored in a register. So R1 is equal to count. Okay. The next step is, so after placing the item, it increments count value by 1. So it increments R1 by 1. So R1 is equal to R1 plus 1. And then it stores the corresponding value in the count. So count is equal to R1. So likewise producer thread will perform the operations. So R1 is equal to count. So what is count value? 7. So now R1 value will become 7. Next R1 is equal to R1 plus 1. So what is R1 value? 7. So 7 plus 1 means 8. So R1 is equal to 8. And then count is equal to 8. So after placing item, so count will becomes what? 8. Let us write the logic for consumer here. So in consumer also, let us assume that internally it performs operations on R2 register. So let us assume that the first statement is, here the instruction number is 4. These are all nothing but instruction numbers. R2 is equal to count. Next statement, count is equal to count minus 1. Why? Because whenever it consumes an item, it decrements count value by 1 and then it places the corresponding value in the count. So here what is the statement? R2 is equal to R2 minus 1. Next, the corresponding R2 will be stored in count. Okay. Like previously we have 8 here. Okay. So R2 is equal to count. So now what is R2 value? 8. Next R2 is equal to R2 minus 1. 8 minus 1 means 7. Next count is equal to R2. So count will become 7. So if you perform operations like this, initially count value is 7. After producer process places an item in the buffer, count will become 8. Next, once consumer process consumes an item from the buffer, count value will become 7. But here let us assume that we are executing the threads in simultaneous manner. We are executing the threads in concurrent manner. 1, 2, 3, 4, 5, 6 are nothing but instructions. Let us assume that first this instruction is executed, and then this instruction is executed, and then these two instructions are executed. Now let's see what is the output that we will get. So what is the initial value of the count? 7. After producer and consumer thread performs the operations, count value has to become 7. Okay, let's see here. What is the first statement? R1 is equal to count. So what is count value? 7. So R1 is equal to 7. Second statement, R1 is equal to R1 plus 1. What is R1 value? 7. So 7 plus 1 means what? 8. Next, let us assume that this instruction is executed now. Okay, fourth instruction is executed now. So R2 is equal to count. What is count value? What is count value? 7. So 7 will be stored here. Next, let us assume that this instruction is executed. R2 is equal to R2 minus 1. 7 minus 1 means what? 6. Next, let us assume that this instruction is executed. So count is equal to R1. So what is R1? 7. Next, let us assume that this instruction is executed. Count is equal to R2. What is R2 value? 6. So actually, after producer and consumer thread performs the operations, actually count has to become 7. So after placing the item in the buffer, count value will become 8. Next, once consumer thread consumes an item from the buffer, then count value has to become 7. But here what is the value we got? 6 as the output. So this is the problem here. This problem is known as inconsistency problem, or this problem is known as race condition. So what is the problem here? This problem is known as race condition. So in order to solve this problem, we use thread synchronization. So thread synchronization is mainly useful in order to solve race condition or in order to solve data inconsistency problem. So why we got this problem here? Here multiple threads are accessing the same shared variable. When multiple threads are accessing some shared data, then one thread is accessing the shared data, then we should not allow other thread to access that shared data. That means here initially producer thread is accessing this shared buffer. So while the producer thread is accessing the shared buffer, then we should not allow consumer thread to access this buffer. So likewise, when consumer thread is accessing the shared buffer, then we should not allow producer thread to access this buffer. Then this problem won't arise. Okay, let us assume that first producer thread is executed. So after that what will happen? R1 is equal to count. So what is the initial value of count? 7. So R1 is equal to 7. Next, R1 is equal to R1 plus 1, 8. Next, count is equal to 8. Next, let us assume that consumer thread is executed. R2 is equal to 8. R2 is equal to 8 minus 1 means 7. Next, the count will become 7. So there is no such problem here. So here, how to solve this problem? When producer thread is accessing the shared data, then only after completing its execution, then only we have to allow consumer thread to access the data. Otherwise, data inconsistency or race condition problem will occur. We can solve this problem with the help of thread synchronization. Now let's see this program. So this program is what? Without using synchronization. Okay. After that, we have to make this program as a synchronized program. So in this program, we have three classes. The first class name is hello. The second class name is my thread, which extends thread class. So this is nothing but child thread. And the third class name is without synchronization demo. So this is nothing but our main class. Our main method is present in this class. So name of the program is without synchronization demo.java. So let's see the first class. So name of the class is hello. It contains a method called hi. So void hi. It accepts a string as the argument, string name. So in this example, what we are doing is we are writing a for loop for int I is equal to 1, I less than or equal to 10, I plus plus, system.out.println within the double quotations hi plus name. So we are printing hi that name how many times? 10 times. So this is the first class here. Now let's see the second class. We know that any user defined thread class must extend thread class. Thread class is available in lang package. Lang is the default package, so there is no need to import lang package. So hello h, a reference variable is created for hello class. Next, string name. So this is nothing but a normal string. Next, this is nothing but constructor. So my thread of this constructor accepts two parameters. The first parameter is that hello reference. The second parameter is a string name. Okay. So here h and name are nothing but local variables, whereas this h and name are nothing but instance variables. Here the instance variables and local variables both are same. If instance variables and local variables both are same, then in order to access the instance variable, we use this operator. So this dot h is equal to h. This h is nothing but local variable. This name is nothing but local variable. Whereas this dot h is nothing but instance variable. So this dot h is equal to h. This dot name is equal to name. So we know that just we have to provide the definition for the user defined thread with the help of the run method. We know the signature of the run method. So public void run. So from this method we are calling hi method. So h dot. Why? Because we know how to call a method object, that reference dot method name. So here already reference is created. H dot, what is the name of the method? Hi of name. Here why we have defined this method is it is not possible to perform synchronization on a predefined method. So in the next example, in the next program, we have to perform the synchronization on a method, but it is not possible to perform synchronization on run method. Why? Because run is a predefined method which is present in thread class. Run method already has some prototype. We should not change that prototype. Okay, so that's why we should not perform synchronization on run method. So that's why here what we are doing, we are taking a class called hello. In that class we have defined hi method. In the next program we perform synchronization on hi method. Okay, so here we are calling that hi method from the run method. Next class, name of the class is without synchronization demo, public static void main string args. So now we know that the execution of a program starts from the main method. Hello h is equal to new hello. So an object is created for this hello class. My thread t1 is equal to new my thread of h comma Ramesh. So whenever an object is created, then what will happen? Memory will be allocated to the instance variables of the class. So in this example for name and h, the memory will be allocated, as well as if there is a constructor, then the corresponding constructor will get executed. Here we have a constructor, so that constructor will be executed. Here what are the parameters? H is the parameter, Ramesh is the parameter. So what is the name of the object? T1 is the name of the object. So now this h contains h, whereas this name contains what? Ramesh. So this dot h is equal to h, this dot name is equal to Ramu. So in T1, what is name here? In T1 the name is Ramu. I'm sorry, what is the name here? Ramesh. Okay. Next, my thread T2 is equal to new my thread of h comma Mahesh. So now also the corresponding constructor will be executed. So T2 is nothing but name of the object. So this h will be stored in this h and Mahesh will be stored in name. Now this dot h is equal to h, this dot name is equal to name. So in name, now we have what? Mahesh. Next to T1 dot start, T2 dot start. Now the thread execution will start. Okay. So the control will goes to the, so what is the use of start method? Whenever start method is executed, then automatically the thread scheduler will calls the run method. Okay. There is no need to call the run method explicitly. So whenever CPU is free, then thread scheduler allocates CPU to the corresponding thread. So CPU executes run method now. So here in this program we didn't perform any synchronization. So in T1 we have name as Ramesh, in T2 we have name as Mahesh. Okay, so run method will be executed. Let us assume that first T1 thread is executed. Okay, h dot hi of name. So what is name here? So what is name here? In T1 object, what is name? Ramesh. Okay, so h dot hi of what is name? Ramesh. So control goes to the hi method. Now what is the name? Ramesh. For int I is equal to 1, I less than or equal to 10, 1 less than or equal to 10, condition is true. So hi colon, what is the name here? Ramesh. So hi Ramesh will be printed. Next, let us assume that this for loop is executed one more time. Next, hi colon Ramesh will be printed. Next, let us assume that CPU starts executing the second thread. Okay, what is the second thread? In second thread, T2 name is what? Mahesh. So now run method will be called h dot high of name Mahesh. So control goes to the high method. So for int I is equal to 1, I less than or equal to 10. So hi colon Mahesh will be printed. Okay. Next, hi colon Mahesh will be printed. Next, let us assume that CPU starts executing thread T1. So in T1, how many times Ramesh will be printed? 2 times. So next I value will become 3. So hi colon Ramesh. Let us assume that this message is printed 3 times now. Hi colon Ramesh. Hi colon Ramesh. Next, let us assume that CPU starts executing second thread. Previously, CPU executed thread T2 for 2 times. Now let us assume that the thread has executed 1 time. Okay. So here, what we have done here? In this program, there are two threads. The first thread contains name as Ramesh. The second thread contains name as Mahesh. Here our target is we have to display hi Ramesh 10 times and we have to display hi Mahesh 10 times. But here how we are getting the output here? Here we are getting the output simultaneously. That means the corresponding 2 threads are executing simultaneously. But here we should not get this output. First, let us assume that T1 has executed. Then we need to get output as hi colon Ramesh, hi colon Ramesh. That message has to be printed 10 times. Next, assumes that T2 has executed. Then hi colon Mahesh has to be printed 10 times. But here there is no synchronization. That's why we are getting the output, the T1 output as well as T2 output simultaneously. So this is the problem here. In order to solve this problem, we use what? Thread synchronization. So we know what is thread synchronization. Thread synchronization means when one thread is accessing the shared data, then we should not allow other thread to access the data. Only when the first thread has completed its execution, then only we should allow the second thread to access the data. Okay. Here we can perform synchronization in 2 ways. The first way is synchronized method. Here we can perform synchronization in how many ways? 2 ways. The first way is synchronized method, whereas the second way is synchronized block. The second way is synchronized block. Here we can perform synchronization only on method and block. We should not perform synchronization on predefined methods. Here run is a predefined method which is available in thread class. We should not perform synchronization on this method. As well as synchronization cannot be performed on a class. We should not perform synchronization on a class. Next, we should not perform synchronization on a variable. So we can perform synchronization only on user defined methods and a block. We know what is a block. A block means a collection of statements which are enclosed in curly braces. So we should not perform synchronization on predefined methods, on classes as well as on variables. We should not perform synchronization. Okay. Let us see this one. What is this one? Synchronized method. Here we have a method called void hi. Synchronized method means before the return type we have to use the keyword synchronized. So that is the only change that we have to do. We have to write synchronized in lowercase letters. So here all are lowercase letters. So synchronized space void space hi of string name. So whenever we perform synchronized on a method, then what will happen is when one thread is accessing that method, then only after completing its method execution, the thread execution, then only the corresponding second thread can access the method. Okay. So here a concept called critical section will be accepted. That means a lock will be applied on a method. Let us assume that first T1 name Ramesh is executed accessing this method. So T1 thread locks this method. Okay. Only after completing its execution it releases the lock. Okay. So hi Ramesh will be printed 10 times. So once the thread execution is completed, then it releases the lock, so that CPU starts executing the second thread. Okay. So this is about synchronized method. So synchronized method means before the return type we have to use as what? Synchronized. Let us change the name of the program as Synchronization Demo 1. So synchronization demo 1 means what? Synchronized method program. So synchronized method means what is the logic here? What is the logic that we are doing? Similar to the previous program logic only, but here before the return type we have to use a synchronized. So we have to make user defined method as synchronized. We should not make this run method as synchronized. Why? Because this run method is predefined method. On predefined method we should not perform the synchronization. Let us assume that T1 Ramesh is accessing this method. So this is a synchronized method, so that a lock will be applied on this method. The lock value will be set to 1. When the lock value is set to 1, then the second thread should not access this method. So whenever the CPU completed this method execution, then the lock will be released. That means the lock value will become 0. Then the second thread can access our method. Okay. So this is about synchronized method. And the second one is synchronized block. Synchronized block means what we have to do is, instead of performing synchronization on the entire method, what we can do is we can perform synchronization on a block, on a set of statements. Let us assume that here we are performing synchronization on this for loop. Okay. So now what we can do is, here we have to write synchronized of object here. Here there is no object, so that's why we have to write this. This represents current object. So within the curly braces body. So what is the change that we have done here? Here this is synchronized block. So before void there is no need of synchronized. Before void, if we write synchronized, then it will become synchronized method. But what is this one? This is synchronized block. Okay. So void high of string name, and we are performing synchronization on this block. This block contains what? This for loop as well as this system.out.println. So synchronized of this represents current object. Okay. Within the curly braces, for int I is equal to 1, I less than or equal to 10, I plus plus system.out.println of I plus name. So here also what will happen? This block is placed within what? This is nothing but synchronized block. So when one thread, let us assume that the second thread starts executing this synchronized block. What is second thread name? Mahesh. So whenever the second thread is accessing this synchronized block, then it sets the lock. So the lock value will be set to 1. So when the lock value is set to 1, then no other thread can access this block until this lock is reset. Okay. So hi Mahesh, hi Mahesh, hi Mahesh. That message will be printed 10 times. So once that synchronized block is executed, then the control comes out from the hi method. Then after that, the first thread, that is nothing but T1 thread, that is Ramesh, will start executing now. So here also what will happen? It will set the lock for that block. So hi Ramesh, that message will be printed 10 times. So once the thread execution is over, then it resets the lock. So let us assume that now the name of the program is Synchronization Demo 2. So here we have 3 programs. The first program is without synchronization. Second program using synchronization, that is synchronized method. Third program synchronized block. So this is about thread synchronization in Java programming language.